How about this problem here? So we have a chemical equation, general chemical equation, and the rate of formation of C is given to you. It says if there are no side reactions, what's the rate of disappearance of B? Why it says no side reactions? Because if there are side reactions, besides, in other words, B and A goes to C, but also at the same time A and B can give you some other reaction. Then, anyway, for this level of class, we don't need to go more in detail about this. What is the rate of disappearance of B? If the rate of formation of C is this, what's the rate of disappearance of B? So it's not really easy to see it. The way the coefficients are there, you have to write things down, right? So you write down what you have. What do you have? You have that the rate of appearance of C is this much. How do you define the rate of appearance of C? Change of C over time. And it's how much? 2.0 times 10 to minus 2 molar per second minus 1. Now, it's appearance. So according to our definition in our lecture, we want to put a plus there. Okay. Just to make sure that we're not going to make mistakes. Now, we want to find out the rate of appearance of disappearance of B. We're going to do two ways. You can write the general rate for this reaction, refer to this chemical equation, and from there we can extract what we want. So if he talks about B and C, we involve B and C. We know C, we want B. So look at B and C. If you write the general equation, the general rate equation for this reaction, refer to B and C, because it could refer to A too, but we don't care about A. Then it will be what? B is disappearing, so it should be what? Should be minus 1 here, change of concentration of B over time, minus dA, d alpha A divided by delta T, but we don't care about it, so we don't write it, equal, and also 2 plus 1/2, yeah, reverse it, delta C divided by delta T. So, if you want to know what is the rate of disappearance of B, then you solve for this, because that's the rate of disappearance of B, isn't it? By definition, yes? So if you solve for that, what are you going to find? You will find out that the rate of disappearance of B is going to be equal to, the plus will make a difference, so you can forget about it. So it's going to be, you just multiply what you have with what? With minus 3, right? Correct? And multiply both sides with minus 3. And that will make me minus 3/2. And this one is known. That's it. So you find out to be, the answer is A. You see how easy it is? If you remember the definitions, it's not really hard at all, right? Any question? That's what we said in our lecture. If you read a book that doesn't say that, then we're going to ignore it. Somehow we have to make straight the definition so we can communicate. Okay? So we said appearance minus disappearance, appearance plus disappearance minus. When you say the rate of the reaction, or it says the general rate, we assume that it's the positive. It's according to the definition. It's positive. Okay? Yes.
The reason why we multiply times 1 over the coefficient, is that just the definition?
Yes, by definition we do that. So that way, it doesn't matter to what component you refer, you have the same number for the rate. That's the only reason we do it. The rate has one value this way, no matter to what reactant you refer. Otherwise, if you publish a paper and you don't know to what you refer, and you don't do it according to this general definition with inverse coefficients, the other person will not know what you're talking about. That's the reason, right? Okay, let's go to the next one. The next one is actually just like the one we saw before, for the part one. I don't know if you want me to do it. You see that it's really the same thing? You want me to do it? How many people want me to do it? Let me see your hand. I guess we're going to do it. Okay? All right. What are the units of the rate constant? K for a 3.5 overall order reaction. So we have the rate of a reaction, which is the rate constant times A, in general we say. And the overall rate, the overall order is 3/2. That's it, right? So now we should know how to do it. Isn't it? Always rate is what? Molarity by second, by time. K times concentration, always we put as molarity. 3.5, and you solve from K. From here you solve for K. And you will find out that will have what kind of units. What will be the answer? C. Right? Should we go to the next? Okay, so we have here, we have substance A reacts according to the first rate law.